Okay, let us begin with lecture number 22. In lecture number 21, we have derived formula for simple interest, and the proof of that formula was very simple. It was basically based on the rate of interest that is being charged, which is percent per annum basis. So that percent per annum helps us to find out simple interest. However, this lecture we will find out how the compound interest is being calculated and what is the formula for that and what is the proof for the formula that we use for compound interest. Okay, so in simple interest, let us take example of 100 rupees is our principal, time 2 years, and rate of interest is R PCPA. Then we calculated that for 1 year, 100 rupees 1 year, we will get simple interest as R. So this is what is the simple interest. R rupees. For 2 years, we will get 2R rupees simple interest. That is what we calculated. Now let us take a numerical example where R is equal to 10 PCP. So what will be the simple interest after 2 years? The simple interest after 2 years will be 2R. That will be for 100 rupees for 2 years. 100 rupees, if I keep 1 year, I get 10 rupees. If I put it for 2 years, I will get let us take principal 1000. So for 1 year, I will get 100 rupees as simple interest. For first year and for second year, 2 years, I will get simple interest 200 rupees. Therefore, if I am putting 1000 rupees as my principal, I will get eventually after 2 years, I will get 1200 rupees along with simple interest. So principal plus simple interest will be 1200. Now, in case of compound interest, what we will do is 1000 rupees is kept in the bank for 1 year. We get interest 100 rupees at the end of first year. So at the end of first year, I get 100 rupees as interest, which I don't only consider as interest, I add it to my principal. So my principal for the next year becomes 1100, and I keep it for one more year. 10% of that is 110 rupees. So now I got 100 rupees as interest in the first year, 110 rupees as interest in the second year, for 1000 rupees which I keep in the bank for 2 years. So here also I kept 1000 rupees for 2 years, I got 1200 rupees back. Now here if I keep 1000 rupees for 2 years, but after 1 year I just put the interest back into the principal, my principal increases by 100 rupees, and hence I get total interest 1210 rupees. That is the advantage. We get 10 rupees more by keeping the same money for same number of years, but if compounded annually, I get 10 rupees more. If not compounded annually, we get simple interest 200, and that is the advantage of compound interest. The money that we make because of interest is more. So now this is what is the example, and therefore these days in banks compounding is done. Nobody keeps the money in using simple interest. It is always compound interest. Now let us, this was a numerical case, let us find out what happens if we keep P principal for n years at RPCPA. How much I will get after n years. So that is what is supposed to be the formula for compound interest. So let us look at that situation. rate of interest R is PCPA, per cent per annum. Therefore, if we put 100 rupees as our principal for 1 year, n is equal to 1 year, then interest that we will get will be R rupees for 100 rupees. So if I put 1 rupee as my principal for 1 year, I will get interest of R upon 100. Now, if compounded annually, yearly, then what will I do? So at the end of my first year, my amount, which I am denoting by A1 is amount after 1 year, which becomes 1 plus R upon 100. A1 becomes 1 plus R upon 100. And now 1 plus R upon 100 is going to be my principal. So principal for next 1 year will be 1 plus R upon 100, and I will keep it for 1 year. Then at the rate R PCPA, how much will this eventually become as interest? So what will happen is, this is my principal, I am keeping it for 1 year, therefore 1 plus R upon 100, that is my principal. Unitary method, this into rate of interest R upon 100 divided by 1, this is going to be my interest part, and this interest part, if I add to my principal, my amount would become, amount after 2 years will be equal to 1 plus R upon 100 plus 1 plus R upon 100 into R upon 100. This is interest for 1 year. This is principal in the beginning of first year. Now I can take out 1 plus R upon 100 common, and then what remains is 1 plus R upon 100, which reduces to 1 plus R upon 100 raised to 2. So if I am putting principal 1 rupee for 1 year, I get R by 100 as interest at the end of first year. It becomes my principal 1 plus R upon 100. I calculate my interest, simplify. My amount after 2 years will be 1 plus R upon 100 raised to 2. And now if I keep P rupees in the beginning instead of 1 rupees, what will happen at the end of first year? It will become PR upon 100. So P plus PR upon 100 will be my amount after 1 year, which would become again similar. And so let us calculate. So P amount kept for the first year, 1 year of operation, I get PR upon 100 as interest. For second year of operation, my principal becomes P plus PR upon 100. If I keep it for 1 year, I get something similar. So I get interest as P plus PR upon 100 into PR upon 100. And then if I add this principal to this interest, then I get amount after 2 years is P times 1 plus R upon 100 raised to 2. This is what is the formula for compound interest, compounding annually, and what will be your amount. So similarly, if you keep doing this, amount after 3 years will be P into 1 plus R upon 100 raised to 3 dot 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 after n years P into 1 plus R upon 100 raised to n. Now this you are supposed to check by doing exactly similar calculations independently, and I am sure you will get this formula for compound interest. Amount after n years for the principal P at rate of interest R PCPA for years n, you will get this formula as a compound interest. Okay, now you spend good amount of time. We have finished it maybe in 5 minutes, but this is important formula and we have derived it very quickly by just using unitary method and the meaning of R PCPA. Right? Now next job is basically now the compounding done after every year. So if we see after 1 year, if I compound for 1000 rupees at 10 PCPA, I get 10 rupees more. So why not compound it after 6 months? Why not compound it after every 3 months? And then why not compound it daily? And so the frequency of compounding, if you increase, your interest that you will get will become more and more. Eventually it will increase slightly, but it will increase, and therefore we need to figure out, if we do compounding after 6 months, what will be the situation. So you may pause the video now, you study this formula well, spend good amount of time, check whether these dots really give you this formula eventually or not, and then start the video again to see how do we develop formula for half yearly. Okay, now okay, for calculating half yearly formula now, let us begin exactly the same way. Suppose we have 100 rupees as first principal, we keep it for 1 year, then I will get R as my interest after first year. Okay, but if I keep 1 rupee for 1 year, I will get R upon 100. This is P, this is N, and this is simple interest or interest. Let us call it as interest. R upon 100. Now, suppose I take 1 rupee and keep it for half years. That means I am keeping the money only for 6 months. If I keep this money for 6 months, how much interest will I get at the end of 6 months? It is R upon 200. It is exactly half of this. R upon 200 will be my interest after 6 months. And now I keep this amount back, 1 plus R upon 200. That is, this is, let us call this amount as principal, which is A 0.5. This is our principal for next 6 months. Again we keep it for half month, and at the end of 1 year I will get 1 plus R upon 200 into R upon 200, and therefore if I really calculate that this is the interest and this is my principal, therefore amount after 1 year will be 1 plus R upon 200 plus 1 plus R upon 200 into R upon 200, which becomes 1 plus R upon 200 raised to 2. So for 1 rupee principal, if I compound half yearly, I get 1 plus R upon 200 raised to 2 as my amount. Okay, so if I do it for principal P, I should get it P into 1 plus R upon 200 raised to 2. Okay, now if I do it for next, let us find out what will be amount after next 6 months. So what should we do? So what will be our principal for next 6 months, that is 1 year to 1.5 year? Our principal will be this much for 1 rupee. 1 plus R upon 200 raised to 2 is our principal. We are keeping it for half 6 months again, and therefore what will be our interest? Interest will be 1 plus R upon 200, that is principal, into rate that we get into R upon 200. This is interest, and therefore amount after 1.5 years will be equal to 1 plus R upon 200 raised to 2 plus 1 plus R upon 200 into R upon 200. Is that right? Or am I making mistake? This into this. No, this into this. So here it should be square. This is my new principal after 1 year. So this into rate of interest R by 100 upon 1. That is what is our unitary method. So that will be square here, and hence what we will get eventually is, if we take 1 plus R by 200 square out, I will get 1 plus r upon 200 raised to 3. So if my this suffix is 1.5, I get power 3. If my this suffix is 1, I get power 2, right? And that is how it will go. So if you find out A2, which you should do yourself, it will be 1 plus r upon 200 raised to 4 for 1 rupee principal. Therefore, for p rupees principal, we will get A2 is equal to P inside bracket 1 plus R upon 200 raised to 4, and that is how we will go. If the compounding is done half yearly, our formula for amount after n years should become P into 1 plus R upon 200 raised to 2n, raised to 2 times n. That is what is the formula when you compound half yearly. Now, when we compare these two, when I compounded yearly, this fellow was 100, this was n. When I compounded half yearly, the denominator here becomes 200, the power becomes 2n. Therefore, now, if I compound every 3 months, my formula should become n after n years should be P inside bracket 1 plus R upon 400 raised to 4n. Okay, that is what is the final formula after 3 months. Now, if you compound it after every month, that means this denominator would become 12 and the power will become 12n. If you compound it every day, denominator will become 360 every day. You will have to really check this number, but that is how it is going to go. Everyday calculations are also easily possible. You extend this formula up to every day, and every day is 1 upon 365. So 1 upon 36500 into 365n would be that formula. Okay, so this is how actually the compounding works. I am aware the calculations that I have done are a little fast, but then you can always pause this video, check my calculations, check your calculations whether you have really understood it or not, and follow the notes. We have written everything properly in those notes. You can read and also understand that and understand this problem, understand this formula. So there is nothing really difficult in this world, provided we go systematically and we try to understand every step that we are doing. Eventually we can derive the most complicated formula for compound interest also very quickly. I hope you have understood this. There are a few problems below the lecture notes which you should solve and get these concepts clear. Now, one question is normally asked at the end of this lecture is, so sir, if we keep compounding after say every month, every day, and every hour of the day, every minute, every second, then will this amount keep growing? So the answer is no. After certain period, it really does not matter whether you are compounding it every day or every hour or every second. It doesn't matter. There is no significant difference in the value of amount after n. So it doesn't make any difference, therefore nobody does it that way. And why it stabilizes is there is this formula leads to basically limit as n tends to infinity, whether this particular quantity will become infinity or it will converge to some fixed quantity, fixed value, and it will never increase beyond that. So it goes into the differential calculus. When you will be in 11th standard, you will learn that. This is typically the formula which we have to find out the limit in 11th standard, and it is not that it diverges to infinity. Okay, so after some time this becomes constant, and then there is no point in compounding further more frequently because the quantity does not increase. Okay, hope you have understood everything that we have discussed in this lecture. See you in the next video. Thank you.